Okay, so we're going to talk about solving linear equations. We're going to look at some of the mistakes that are common for solving these. So we're going to, given a problem like this, solve this equation in yellow. So before we can really solve it, we need to ask ourselves, what are we trying to do? What's our goal? Alright, well, our goal is to get the simplest equation that we can get, which in this case is always going to be x equals some value. We're trying to get there. And the way that I get there is with inverse operations. So if I have operation, the operation and the inverse, so my inverse operations, if I add, the inverse subtracts, subtract, and I add, multiply, the inverse is divide, and division, the inverse is multiplication. And why does that matter? Well, if I have something like 10x equals 30, my goal is to get the x by itself. So I want something like x equals something down here. The way that I get there is with my inverse operations. So what I'm going to do is the opposite of multiplying by 10 is dividing by 10. Do it to one side, you do it to the other. And why this works is 10 divided by 10 gives me 1 times x. And 1 is the multiplicative identity, which means that this is going to give me back my original value of x. So I'm going to get x equals 3. Okay, so that's what I'm trying to do with my big mess. That was my simple idea for what we have going on, and I want to do it for what we have up here. So I always start by dividing up my equal sign. Alright. And then I'm going to distribute. I'm going to push that 3 through the parentheses and work on making things simpler. We're trying to get to that x equals something. Alright, so I do that. Carry down my 10x. Combine my like terms to give me 2x. Carry down the 6. Now the opposite of subtracting 6 is adding 6. I get 2x equals 12. I divide by 2 and I get x equals 6. Okay. So again, run through my process. I want to keep track of what I'm doing to both sides. And right now I have a conjecture that x equals 6. Well, I can check that by plugging it back into my original value. So if I get negative 10 times 6 plus 3, 4 times 6 minus 2 should give me 6. So this is negative 60 plus 3 times 24 minus 2 is 22. Negative 60 plus 66 does in fact equal 6. It checks out. I did it right. Okay. So let's say we had another one. A little bit more complicated, but same idea. I'm going to distribute and distribute, distribute and distribute. So I'm going to get 4x minus 2 equals 12x minus 4. I'm sorry, not equals. Minus 12x minus 4 equals 2. I'm going to combine my like terms. So all my, I left off an x. All my values with x. So 4x minus 12x, we want to really keep track of that minus sign, is negative 8x minus 2 equals 2. I add 2 to both sides, and I get negative 8x equals 4, or x is negative 1/2. Alright. So those are ones where we have all our variables on one side of the equal sign. We may have something like this where we have variables on both sides. Well, what we need to do here is to, first off, get everything to one side. So I'm going to bring everything from that's common from the left side to the right side. The way I'm going to do that is by subtracting 3f from both sides. And what's happening is this gives me 0, and 0 is my additive identity. So what's going to be left over here is -2. 4f minus 3f is f. The plus 5 comes down. Now it's simple. I subtract 5, I subtract 5, and I get -7 equals f. And I could check that to make sure.